everybody. Hello. My name is Etienne. I'm a software developer from Canada. Just a little bit. I run a small consultancy called Software. So small startup where we specialize in Kotlin development. Before I get started, I want to, like I say, it's always important to give a huge thank you to the conference organizers, and in this case, first conference in Asia. So thank you so much for organizing this conference and having us all over here. I feel very, very grateful. I'm sure the audience as well is pretty cool as well. I also have to thank Google, which makes a lot, but I'm part of Google's Developer Expert Program, and they provide support for people that program travel and speak about Android. So very grateful for this as well. So thank you, Google. All right, so today we're going to look at we're going to be looking at how to use the MVI architecture in a multi-platform environment. Right, so the thing is, with modern applications, you have to target iOS, target Android, and the web. That has basically become table stakes for most projects. If you're a big company the size of a huge problem, you just hire a lot of engineers. If you're a small startup, well, that would be really perfect. Probably can't get all the different architectures out there, so what would we do, right? Kotlin Multiplatform is a very proxy solution. It allows you to target multiple platforms, not only mobile, but also the web. So, as I mentioned, I run this small consultancy agency. The reason we decided to embrace Kotlin Multiplatform is effectively it allows us, or the royal us, working freelance consultant, it allows me to punch above my weight. It's the target basically platforms for customers without going insane and spending most of my waking hours in developing. So I want to share with everybody here what I have learned working on community projects so far. So the strength of Kotlin Multiplatform is that it allows you to write native applications. So that means that your apps built with PHP are able to target the latest and greatest APIs for your target platforms. And we're talking the native APIs. So that's a critical difference from other cross-platform environments like React-Native and Flutter, who offer really compelling services and compelling frameworks, but you're always going to be playing catch up with the actual native frameworks, right? So Apple or Google comes out with a new UI framework, well, somebody has to go in and fit that. It's very hard. So you're always a little bit behind the best practices. And also you can tweak your apps just so they have that specific iOS look or that specific Android look. So obviously, though, if you're going to write code that targets native frameworks, that code is going to be effectively single-use, right? Even if it is called written So to stay efficient, you have to just put some effort where it matters. So I came up with a little code reusable to help guide my own efforts and hopefully yours. Very simple stuff. So the common Kotlin code is your best payoff. The code that you write in Kotlin in common libraries will be usable from all the different platforms. So effectively, you want to have as much code as possible written in this part of your stack. Android is an interesting one because it's the one I would call where you dig for gold. Basically, if you are coming from an Android project, as a lot of people on KNP do, you can dig into your Kotlin Android project and your Kotlin source code to bring code back into the common library. So that's a good place to look for reusable code. But inherently, once you have, say, a compose library, obviously you can't necessarily use that on iOS. Right. The slightly less reusable code, actually fairly single-use code, is the Apple stack. So here you're going to be targeting iOS, so you're going to be writing code probably in Swift UI or potentially in Objective-C, depending on how old your stack is. And finally, when you're writing a web client with Kotlin JS, well, your code is technically reusable at that point. But what I found in my own experience is that Kotlin JS code, although pure Kotlin and really, like something that you would think you could reuse, tends to get a little bit polluted with web concerns. Because whenever you need to access a web API, you tend to sort of
have to shim it with JavaScript calls. And so after a little while, your Kotlin JS code tends to not really be portable, which is fine because effectively it's client code, but that's something you need to think about. All right. So my architecture of choice with reusability in mind has been MVI, which you probably know given the title of this talk. Personally, I found it not only helped me reuse code, it also really helped me focus on the right problems at the right time. So to get started on the right foot, I'm going to give a small explanation of what MVI is, and I'm going to review some of the core concepts with you. So my opinion on MVI is that it's more about adopting the principles and the philosophies than by adopting any strict, rigorous framework. So there's a few libraries out there. I'm going to mention them a bit later. But I've always been sort of a proponent of rolling your own solution and taking parts of the standard libraries of Kotlin and more of the more standard libraries you see out there for different approaches and using those to build my own MVI solution. So there's about 4 or 5 big principles that I tend to really stick with. Those are unidirectional data flow. We're going to talk in a sec about immutable state, which we've heard a lot about today, and I think it's pretty common nowadays in the industry. Functional programming principles, which are something most people are getting more familiar with thanks to Kotlin, but we're going to review a few of those ideas. Reactive programming, also very popular lately, so that's an easy subject to approach. But those are the 4 big ones that we always try to bake into our MVI and be sort of purposeful about and really think about why are we doing this and what is it bringing us as stability and everything goes. All right, so unidirectional data flow is a very simple concept. With MVI, user interact with the view. So when you interact with the view, you create basically what are called view events. Those events would typically be converted into something called an intent. An intent is processed by your model. The model, by processing the intent, will change its own internal state. And subscribers to that internal state, which are typically views, then get a chance to refresh themselves, and so on and so forth. So unidirectional data flow is not magic, but when used correctly, it allows you to modularize your code in very sophisticated and interesting ways. Now, this is a somewhat scary diagram, but if you apply the concepts of unidirectional data flow correctly, what you find, in my own experience, is that you still write very tight concerns around your business logic, and the models between each other tend to not influence each other unduly. So that's one thing. But another critical principle of MVI behind all this is that it uses an immutable state. Right? So immutable state, for those not familiar with it, we rely on data classes in Kotlin to enforce immutability. And the benefit of using those kind of classes is very simply that if you try to modify a value like this, code simply doesn't compile, right? You can't even allow a view is not able to change state and mutate it out of bound because you have been using immutable data classes. Mutability is obviously super important. Without it, we're going to risk ending up with shared mutable state. So that's whenever you have, very specifically, data persisted over time that can be modified and that is concurrently accessible, so that multiple parts of your program are able to access this mutable data. Right? So if you've never heard of shared mutable state, you have, because I've been at most of the conferences today, but if you basically use that, in most programming circles nowadays, it's like the root of all evil, right? Like that's where bugs usually come from, and you want to avoid that as much as possible. And it is one of the key programmings behind functional programming. And it's one of the key concepts that MVI adopts and would, encourages very much. Now, functional programming also promotes the use of pure functions, right? It's in the name. Pure functions always return the same value for a given set of arguments. They have no side causes or side effects. And that also means that they can't mutate the value of a variable or read from disk somewhere, which would, effectively break this contract. Now, obviously, most applications will eventually need to store state. It's important, and you're going to need to interact with the outside world. And so, effectively, MVI architecture can't be a pure functional approach. It only borrows from functional programming. So that said, though, MVI implementations will use various strategies to isolate the side effects heavy code from your more functional code. So one of the big principles here is reactive programming, and that's where we borrow from to achieve that. So reactive programming is all about creating streams of signals and the subscribers that can react to those signals. In MVI, we create components that expose those streams of model state on the output side. And on the input side, we had handler type functions. That stays true for the views as well. Different implementations, but the concepts are similar. You got an input side and an output side, and that's the contract you try to respect. So, of course, this is code that's valid for JS, Android, and JVM, and so forth. Swift is different, and we're going to take a look at that in a bit. All right, so those are the big concepts behind MVI. One of our goals with MVI is to create very clear boundaries between what you have as code that does create side effects and the more abstract business logic code. So that approach helps you reduce the complexity and allows mostly for a better code reuse, which is all about what I'm about today, right? I'm talking about how to reuse our code most efficiently with this architecture. All right, so context is king. And in today's discussion, I want you to imagine that we're going to be building a small mobile app. Now, as you can sort of guess from this little emoji, you're maybe just like me bored with to-do apps. So instead, what I've been playing around with lately is a habit tracker app. It's not that much different, but there's a bit more complexity and it allows you to dive into more crunchy examples. So effectively, if you want to do a habit tracker app, imagine for a second you're going to want a screen like this one where the users can see their goals and how they're doing in their progress for each of those goals, how many glasses of water did they drink, and how many times have they been to the gym this week, etc. Right? Each bar represents a habit. We're going to be tracking habit entries as well, the second class down there, and that helps us, let the user know how they're doing relative to all those goals that they've been setting themselves. Right. So we also need a screen where we can create new habits or edit existing ones. So that's your typical create or edit type screen. Habits will be tracked weekly or daily, and based on their types, they'll represent a plane counter, like those gym visits I mentioned, or a one-time event, like call your parents this week, the amount of water you're drinking, whatever, right? So now we have to think about, okay, this is a multi-platform project. How are we going to structure this? And I'm keeping a very flat and simple structure, right? But this is basically the idea. You want to be able to target Android, iOS, and the web, and you want to have your layer of common code. So workflow-wise, it's worth noting that for each of these stacks, you're going to need a different editor. So on Android, you're going to be on Android Studio because of all the tooling that you get. On iOS, you might want to use Xcode and AppCode at the same time, which is what I've been doing. Xcode works fine, but for people who are used to Android Studio, AppCode is a worthwhile investment, I would say. On the web, effectively, IntelliJ works better, and that's a few of the kinks that you're going to meet with Kotlin Multiplatform is that the support for each of these stacks varies sometimes a little bit wildly. For example, today I've been struggling with Android because there's a very recent bug in one of the new betas where Electric Eel and Dolphin no longer can open Kotlin JS projects depending on how you configured your Gradle files. You have to roll back to Chipmunk. And so sometimes IntelliJ is a better choice with that. So you might end up with 4 editors open at once, which is one of the downsides with Kotlin Multiplatform. Okay, let's look at the project configuration now. The top level Gradle build file, nothing special. It's your very silly, typical little file. The real star of the show in most of the Kotlin multi-platform setups is the libcommon module. So effectively, you need 3 plugins for the type of project we're looking at today. You want to have the Kotlin multi-platform plugin. You want to have the CocoaPods plugin and the typical Android library plugin. Those are the 3 big ones. Now, first, you want to figure out how to configure your Android plugin. If you're from Android, which most likely you are, given this is an Android conference, nothing special here. Very basic vanilla configuration. The Kotlin block now, slightly different, but wait, yes, so, oh yeah, sorry, I'm tripping myself up in my little animations. So the Kotlin block is where the bulk of the configuration lives. We start configuring the Kotlin Multiplatform plugin by adding all the platforms that we want to target. So here I have a few more than I really, strictly speaking, need. I have a JVM vanilla one that you could use if you wanted to target as desktop apps as well. I have an Android block, an iOS block. The iOS simulator block that you see here is important if you want to be able to run your code on the the iOS simulators, as you would guess. And the last block right here, the JS block, this is typically what you would have in there. The IR flag you see here is for the new internal compiling representation stuff that they've added in the last few months. Well, actually, they've added it a while back, but it's become stable in the last few months, I would say. Yeah, that's about it. So all that we really needed to adjust are the JVM and the JS blocks right here. But if you ever did target other native platforms, because you can target native Mac apps and native Windows apps as well with this kind of stuff, then the configuration becomes fairly complex, but it is possible to do this here. Afterwards, you want to configure your different source set in your multi-platform library. So this is how you go about it. It's verbose, but it's technically nothing super difficult. The thing to remember here is that your common main, common test, those dependencies are going to be carried over to the platform-specific blocks as well. So in certain cases, you basically get away with putting nothing down in any of the native platforms. But in certain other cases, depending on the libraries you're including, you have to put a common one up there and introduce specific ones in the different platform blocks. So an example that I'm not going to show in detail here, but if you're using Ktor, Ktor has a base engine that it can use to communicate with the server. You can set it up as a curl engine or different types of platform-specific things. So for iOS, you would need to tweak that. And for Android, you wouldn't touch it because the default engine would work quite well. Closing off the configuration stuff, which I know is a bit dry, but it's a big part of where you spend your time when you start Kotlin Multiplatform project. The specific CocoaPods configuration. So if you're not familiar with CocoaPods, it's a dependency manager for Swift and Objective-C projects. So it's something that when I used to do Apple iOS development 10 years ago, we did not have, and I was always sort of happy to have in Android land. And now they have not only CocoaPods, there's a few more available, but the CocoaPods one has the plugins and all that you need that are available from Gradle. So that's what we end up using. Here we configure different things that will actually translate into the Swift project, because this will appear from the Swift project. Not only will our Kotlin library appear as an available framework on your iOS project, but CocoaPods on top of that, on the Swift side, you can configure with your own other dependencies to add more stuff if so you need to your iOS project. All right, so how much code reuse can we actually expect out of this project? Structure, well, I've touched on it a little bit, but well-written model code typically lands entirely in the common layer. So you can put pretty much, in my own experience, everything there, which is pretty awesome. Views, on the other hand, tend to be very platform-specific. If anything, that's actually a feature of the KMP approach, right? We want to be platform-specific. All right, so let's see. We're going to start with the common block. So the common library will store, among other things, the models. So here we have a habit state. That's the state that our model will store, but like I've described earlier. Habits and entries are bundled into this state. And then this app, the way I've handled things is I've created a cache state to sort of track how things are being loaded and refreshed from server. We're going to dig into that in a sec. The other thing that we want to ask ourselves is how much of the model logic can we build in the common module, right? Is it really true that we can build everything in the common module? And in my findings, the answer has been yes. So the first thing you want to think about, though, is what interface the model exposes to the views. So here we're first exposing the habit store, which is a state flow, and that's effectively our model's output. Next, having access to coroutine and flow, I think needs to be mentioned is a really big deal, because don't forget, we get access to this stack from all three platforms. So that's what really empowers Kotlin Multiplatform, in my opinion, to really deliver the goods, right? Here we have a state flow that allows you to publish your common model state everywhere. And on the input side, well, MVI models would typically expose one or more intent processing function. So in a lot of MVI approaches, you get only one processing function like this one, where you pass in intents, and then you would have somewhere else like some sort of intent builder layer, right? So your view would generate events, and these events would be taken in by this dispatching layer, which would turn them into intents and pipe all the intents into your processing function on your model. Now, depending on the MVI approach, you might do that, or you might do something like this. In my personal experience, I've actually found it a lot easier to work this specific way. Now, specifically also with Kotlin Multiplatform, it tends to make a lot less boilerplate and tends to be a lot less class happy, if you will. So having this approach does have a few benefits. Now, the thing is that one of the big benefits here is that you basically don't expose any type of action to the rest of the system. You're being very prescriptive about what can be done with your model. And anyway, we're coming back to that in a sec, because I tend to write rule enforcement code in my models, but that approach is good for that thing. So now, yeah, okay. So sorry, I'm getting lost with my own slides, but I'm there. So basically, the idea here that I was talking about is that we want to be able to validate what's going on, and to validate that the view is attempting things on the model that actually make sense. And intent validation is basically what I call this. So I always tend to have a state machine in my models. So I showed you earlier that we had a cache attribute. So for this habit tracking app, the idea is that you have all your habits and all your entries of habits kept in memory. Doesn't scale well if you have a gazillion entries, but for a habit tracking app, and for this example, it's simple enough, right? The problem is, though, that you don't necessarily want to be reloading your list of habits and entries from the server all the time. So in this case, I decided that we would keep everything in memory, and as the user is operating on their app, we're assuming that they're probably a single app user and they don't have like 5 different phones lying around. You know, if they enter an entry or create a new habit, what we're going to be doing is optimistically caching that in the model. Now, the idea there being that on model initialization, we can load the habit data from the server once, and when we're done, when the user adds habits or entries, we can send that data over to the server, no problem, and we're going to end up in a busy state while that async operation is happening. And once we're done, we can save that information in the modified state. Now, the model itself is not changing, but what we're noting is that we've done the call to the server, we take the answer back, and we're going to increment, or rather change, only the delta of that operation in our memory model, assuming that not everything has changed, and optimistically assuming, hey, we only needed to change that little delta and things are good. We are ending in a modified state because we do want to be able to track the fact that we have a bit of a local dirty copy if ever we need to update it. So if, for example, a request failed at some point, we could simply say, okay, well, we failed to reset our application. We'll prompt the user to do something about this failure, either go get a network signal if that's why we failed, or perhaps check your credentials if you failed because the authentication has not worked. And we go back to a loading state, and we can keep going with the state diagram. So to enforce this state machine, which is the enforcement part, is really the important part here. What I would usually do is build a valid process function right over there that will soft fail any type of intents that are coming in from the view that are trying to act out of this. Like if you think about it, basically imagine that your view is, you've just refreshed your view or you've done an operation, and you're supposed to show a busy signal to the user, right? A busy spinner. And the client side of things has not done that, and somehow has exposed a button that allows the user to start, spamming actions onto the model. With this approach, the model can simply say, "Oh, wait, that's not possible," and drop that to the floor. That request to the floor, that intent does not happen, and you can log to the server, "Hey, something's fishy with our client views right now. We're attempting out of bound commands and intents, so do something about it." All right. And if the cache, for example, in our case of reloadable, right, if it's not modified, failed, or reloaded, we ignore the calls to reload intent because that's not something that we could do, right? The other thing to note is that sometimes in MVI approaches, I find that having an error channel is kind of interesting. So what this is here, you'll notice it's not a state flow, it's actually a shared flow. So whenever you have cases where you would want to pop a little, not a toast nowadays, but if you want to pop a message to you saying, "Hey, something has failed," without necessarily wanting to stop the world or having them, take onto an action and so on, you can send these messages here. And that's a way to signal to your user that something has happened without necessarily having that take over your whole state flow. The other approach, besides soft failing, is to simply saying, "Well, actually, I don't want a soft fail. I want a hard fail." And that actually sometimes can be a good approach if your testing frameworks are super solid. Basically, you want the errors to happen pre-release. You want to run your suite of tests, and if somebody did forget to hook up the right buttons to the right views or are allowing for commands to go through when you're supposed to be refreshing, you just explode the app right there and detect the failure and go your way and fix that before you release. That's also another valuable approach. Yeah, so in my own experience, honestly, though, the second, in my own approach, I know that some people don't necessarily like to hit the state machines right so early, but in my own personal experience, whenever I have an auth model, that's where I start going like, yeah, that's an actually necessary piece of the puzzle. Right. All right, so another big common code cornerstone is the Ktor library. So Ktor allows you to have your common REST API calls, right? All you get, posts, puts, deletes, and whatnot. It makes it really easy to define your REST calls as well. So you can see here a little bit what a REST call definition looks like with Ktor. If you're familiar with retrofit, which on Android is usually a go-to, it's a similar amount of work type of approach. And obviously retrofit's not yet anyway being available elsewhere than Android. Ktor is like a really good alternative at that point. Ktor also makes it pretty easy to serialize and deserialize your code. So we can see here that when we get the habits, like for example in this call, we can pretty easily just get our data out and have it demarshalled and everything. All right. Now, I'm getting a bit more into the territory of platform-specific code. Now, since this is 45 minutes and I don't want to hold you here for like 2 hours, obviously we're not going to do a super deep dive, but I will, for all three platforms, focus on three specific things. Effectively, what type of view framework are we using? How do we hook into the outputs of events that are coming from the model? And how do we feed events and intents, rather, back into the model? So here we have Compose, our declarative UI framework of choice. The high-level concept here is that you declare your views as functions, that these data these functions consume, Compose will be able to sort of smartly see when the changes happen, and we build different sections of your UI based on the changes in that information. So the habit view here will take a habit state, will take in a habit state and an event handler. Now the scaffold right there allows you to configure the top bar, the bottom bar, and the floating action button that we see in the view. The tail end function right there helps us build a lazy list from the habits that we have in our model. And you can also see that there's an internal editing model state right here. So what's interesting with Compose is that a Compose view can have its own private internal state, which is something we actually used to have like forever, right? If you think of text fields, for example, they had often their own little state and would serialize to disk and with varying degrees of success depending on how your app was configured. Well, here it's a similar concept, except it works nicely. we can, by using the remember savable DSL right there, declare this inner mutable private, right? It's not shared mutable state, it's basically private mutable state. We can define that this piece of information we want saved to the disk every time there's a reconfiguration. So that's really neat because outside of the view, we don't need to worry about its own internal state. Here, what I basically had in mind is just to show an example. It's a bit of a contrived example. It's not really great UI. But imagine that if you press the Fab button and you enter an edit mode, then the view internally is able to reconfigure itself, offer these new affordances, show these new affordances to the user without your model necessarily being aware of it, because the model doesn't care at that point, right? All the model is caring about is what type of intents are coming in and what type of info it has and publishes. So it does not need to know that the view has entered this sort of tier state that offers different things to the user. That's a pure view concern at that point. Really interesting thing I found, because it really helps to better sort of detangle the responsibilities between different components. All right, so one other of my favorite things about Compose is how easy it is to attach a model to it. With Habit Store, you only need to call collect as state. That's it, you're done. And then you pass that into your Compose function, and most of the rest is fairly automatic. On the output side, processing view events is also very easy. So here we see that when you use a when clause, you can be confident that you will not be dropping things on the floor, right? The when clause will force you to handle all the possible events that are coming out of the view. And here you might have noticed the dispatcher layer I was showing earlier. Since we took the approach of defining our valid processing function straight onto the model, you can basically cut out a middleman and keep things fairly simple. Now, you might want to change your approach. Obviously, things become complicated. For me, the idea of layering different things in MVI is really more of a question of how am I organizing my code? How clean is it? And I'm not personally very strict about always holding to like, oh, we have to create this layer even though it's not doing much, because eventually it will do stuff. Like, I feel like that's not necessarily, that can be overkill for no good reason. Also, for simple model, it's interesting in that you can trigger intent processing fairly trivially, right? Just a simple call, things are done, right? All right, so we're going to move on to the JS side of things right now. So for Kotlin JS, Kotlin X HTML has been, for me, my basic library of choice to generate views. If you look at what the community is doing, a lot of people are using React as a layer with Kotlin JS as their go-to view component library. Quite honestly, I felt it was a bit overkill to do that for my own projects, which were very simple. So I've only used Bootstrap as a view library. What's interesting with Kotlin JS is that you can import whatever pieces of the web environment ecosystem that you're interested in. So Bootstrap is it's effectively just a dependency import in the right places, and you can start using it in your project. So Kotlin X allows you to build these different structures. So in this case here, we're creating different pieces of the document that we want to see on screen. Now, once you put that into a bit more of a structured view component, things look a bit like that. So here, for example, you're going to have a main div. That's something that I typically expose to the rest of my web app. So I can build different view components. And at the top level, where we're a bit closer to the DOM, we can effectively build the view components, pass in the right things, pass in the right dependencies, eventually attach them, and then use this exposed main div, or this div, actually. In this case, it's main, but if you had multiple components, you could give it another type, add that to your main HTML page, and you're good to go. Then the other big thing to notice here is this attach function. So here I basically built this myself, but the concept is fairly simple. You pass in your input and your output. So you pass in your state flow directly, and you pass in a handler. And when you want to collect the data from the model, then you call collect on this, and then you pass in the values to the right pieces of HTML, update them. And so, funny enough, you're very close to the actual DOM, but it really plays out fairly declaratively, and you're in similar sort of mental space than if you're doing compose, which is kind of a bit odd to say, but that's what I found for myself, yeah. Event handling is nothing special for JS. All you have to look at is the click functions right here and passing in your event handlers. The slight difference is that I've been using a sort of middle events channel, and which I then only use at the attached level right here. View component, what does that look like? This is not actually necessarily something I recommend everybody copy if they wanted to do their own HTML project, but this gives you a bit of an idea. You still have a coroutine scope that you are working with. In JS land, this is slightly acceptable because we only have one thread. On a typical mobile app, I would be passing in the coroutine scope. But yeah, I found that this is an approach that works pretty well for the web. Could probably be improved, but that's what it looks like. All right, we're going to move on to iOS, a bit more familiar land. So moving to Swift UI. Swift UI is similar to Compose. It's what I call a declarative view system. I'm pretty sure that the Apple documentation says the same thing. Thanks to a previewing system, you can see the quick impact of changes that are done to the code, very similar to what we have on Android. You get a system to manage a view's internal state and properties. So a bit like the data I was showing you earlier, the inner mutable state that the view had in Compose, we have a similar framework for iOS that allows you to effectively share states in a safe way in and out of the component. Now, this is not something I use in my MVI approach. You'll see why in a second. Then the other thing to note here is that based on the data the view consumes, it builds itself dynamically. So again, another parallel to Compose, philosophically, same kind of approach, really, in my opinion. So this is just the preview window. That's what happens when you go a bit too quickly in the ordering of your animations. Sorry. All right, cool. What else did I have to say about this section? Oh yeah, before I move on to the actual hooking up of things, CampKit. I feel like, who here has heard of CampKit? I feel like I'm going to get a few hands, right? No? Yeah, okay. So this is your example Kotlin Multiplatform mobile project of choice. This is built by Touch Labs. They're based in New York. Really awesome work here. So if all you're curious about is the mobile side of things, you go there, you're going to get all the documentation and all the configuration options that you need. There's a lot of very good examples on how to hook up with different Android libraries. So I've taken my own approach I've taken their approach, it's not my own approach, of how they've hooked up flows to Swift views, and that's what I'm going to show you right now. So the way that we can consume the Kotlin flows from the Swift UI framework is first you need to create an adapter layer on top of your flows. So that's what's going to allow you to expose properly typed flows to Swift as simple callback-based operations. So you're just creating a wrapper on top of flows so that it's going to be easier to consume from Swift. These adapters allow Swift code to also cancel subscriptions as needed. So that's how you implement that. That's the CampKit code that I've taken pretty much verbatim on how to write these adapters. You can still expose habit model itself. So as you see here in the val, I keep the habit model available to the Swift UI side. And the idea there is not that you're going to be consuming the state flows, but that you can actually call the processing functions directly from Swift, and there's no downside to this. If you want it to be a bit more rigorous, well, you could take a different approach, but as you see, I have taken the approach of layering things in the next segment. So that's the point I was trying to get to. So, so once the adapted model is made available on the Swift side, this is what kind of Swift code we're looking at, we can create an observable object. So observable objects, I hesitate a little bit to say this, but almost think of it as a flow on the Swift side. So it's the framework that Apple gives you to be able to effectively build reactive systems that works on iOS. I'm not a super fan of it yet, but then I have very little experience with it, so I am not the best informed person to tell you that this is better or worse than flows. I just find it a little bit more clunky, and you'll probably see why if you follow along with me. Once you have your observable object that you've created, what you want to do is to get your habit model. I wrap it into the adapter. I've just shown you the Kotlin adapter I showed you a second ago. And once I have that, then we have to write these two functions, an activate and a deactivate function. That's basically what's going to allow Swift UI to start and stop the observable. And then you see here, I was talking a second ago about how being a bit more prescriptive as far as or hiding away the habit model. So here what I've decided to do in my approach is to take the processing intent functions and actually shim them on this observable object. Now, there's different ways of doing this. I'm just saying that's one way I decided to pick. I felt it was a slightly better organized thing. Right, so once you have your observable object and it's ready, all that's left is to hook it up to a view. So as the view appears and disappears, you're going to have these callouts, these callbacks that are going to be done, right? So on disappearance and on appearance, you're going to be activating and deactivating the observable object we just created in the previous step. That's actually your pub subsystem right there. Then when you access the map of habits straight from inside the view, as you can see here, in a similar way to Jetpack Compose code, this will cause the view to rebuild itself as the model state changes. Now, the big difference with iOS and Kotlin really at this point, Swift and Kotlin at this point, is that the for each function that you're seeing there, that's not like a standard Commons library type way of unrolling maps and collections. That's a specific Swift UI unroller that will be aware of what is part of your list and will be sort of doing special operations so that everything works fine with Swift UI. So that's similar in concept, but different in actual implementation to what we have on the Android side of things. And once you're done with that, the last step that you need to take is to hook up your button click listeners, as you can see on screen here. And once you've done that, you have a working UI. All right, so that's about it for iOS. So as you can see, it's not like a gazillion steps. And we saw for all of the 3 different platforms, what type of view building system you have available to you, how to hook up to your flows, and how to pipe back events and intents back into your model. One of the last technical bits I wanted to cover quickly is Coin. So I'm a bit short on time, but Coin is your dependency injection, one of your 2 dependency injection choices you have with Kotlin Multiplatform. You can also use something called Codeine. I've used Coin effectively because I feel it's a bit simpler to use, but that's very much personal choice right there. So what does Coin look like? I focused only on the configuration aspect of things. I'm going to go quickly over this. But as you can see, you have your DSL that allows you to define singletons, or that could allow you to define a creator of different instances, a bit like Dagger or any other BI engine. Then you need to be sure to but then you can lazily inject things using the by inject right there. So whenever somebody accesses off model, it'll be fetched from the Coin tree and created as needed. And then you just really basically need to start Coin in the right step of your lifecycle on Android, on application. Very similar to what you see with Dagger. So I've shown the block from application. Yeah. That's basically, there's some of that code I need to mention. I could be living in your common layer. So it's going to be effectively dependent on how you want to organize things in your own project. For Swift, the module code I tend to end up with on the Kotlin common side of things, like most of my dependency definitions are not going to be done in Swift. And this is more like a boilerplate to start Coin and making sure that we pass in the right information when needed. So here we see there's a little bit where we can pass in some of the iOS stuff into Coin while it's initializing to make it available to the rest of the app. And then you get a single instance of Coin right there that's accessible from elsewhere in the iOS Swift code. And this is the starting point really in your thing. So yeah, I don't have the JS example, quite honestly, because I haven't used it yet in JavaScript. So I'll have to apologize for that. I'll have to wait for another time. Okay, so we're pretty much home stretch. I've actually reached my time limit. What are these slides about? Compose is really awesome in this setup. Don't forget that there's Compose for desktop and that Compose for web exists. I haven't used it because effectively I found it a bit crashy at this stage, but it's something I'm really curious to see hit beta and start trying to use in my web projects. I feel like it's going to improve a lot the story there with how I build my screens. Firebase is an awesome library when you're taking the MVI approach. Since it's reactive, you can basically write your models on top of Firebase, and it makes for a lot less code. So I just want to mention that. It's a really powerful library to look at. I'm talking about the database real-time stuff out of Firebase. It's really nice to use, and since it's available on most platforms, it's like a nice component to add to your multi-platform apps. Other tracks to explore, last little notes. So if you do want to have a prescriptive MVI approach, these two libraries are actually very good. They're more formal MVI stacks, and as I've looked into them, like, I believe that they mostly can be used multi-platform without too many issues. So that's Orbit multi-platform on the right, and on the left you have MVI Kotlin. So I recommend you check out these two. They're really good stacks. And that's about it for me. What I do like about Kotlin multi-platform in general is the sort of idea of your T-shaped skill set. What I mean by that is that you need to be a good Kotlin generalist to be able to approach these kind of projects, but you also sort of get to leverage, if your team is more than one, the expertise of anybody that has done like extensive iOS or extensive web, or really aware of their ecosystems, or in my case, extensive Android experience. Like, it's super interesting to me that we potentially can build projects now where everybody has this sort of common language to speak about Kotlin in the common layer and can share ideas through that, but that your own long experience and deep experience in the stack can be used and can benefit the others on your team in a way that, you know, sometimes in other organizations, when the iOS team doesn't speak to the Android team, doesn't speak to the web team, it's kind of sad to see those silos. So I have high hopes for Kotlin multi-platform in the future. And thank you very much for your time. That's it for me.